Well, hello everyone, this is Mohammad Badruddin. Hope you all are doing well. Today we are going to solve lab number 7 from JWT Attacks module from the Web Security Academy, and this lab is all about JWT algorithm confusion. So before going to the lab, this disclaimer as always for you that this video and its contents are only for educational purpose and I do not support any unethical or illegal act. That's been said, if you like the content, please like, subscribe and share as much as you can. So let's go and we will solve this lab. So the first thing first, what is JWT algorithm confusion? In this lab, we are going to enforce the server to verify the token with the algorithm or with the key which we want. So even if a server uses a robust secret, means a secret which is very hard to brute force and you cannot brute force that secret. So in this case, there could be a chance of algorithm confusion vulnerability. So in that case, you may still able to forge the valid JWT by signing the token using an algorithm that the developer haven't anticipated, right? So let's go and we will see what's inside this. So I already open up here. Algorithm confusion attack. Algorithm confusion attack, also known as key confusion attacks, and it occurs when an attacker is able to force the server to verify the signature of a JSON web token using a different algorithm than is intended by the website's developer. Fine. So we know that there are two kind of algorithms like symmetric and asymmetric. In symmetric algorithm, we have only one key that is used to sign and verify the token, and in asymmetric algorithm we have two keys. The server sign the token with the private key and verify the token with the public key, and this public key can also be shared, but the private key must be secret. How that vulnerability arises? So here is an example. You can see there is a function to verify the signature, and that function needs two arguments. One is token and another one is secret or public key. It is going to fetch the algorithm, that which algorithm is used in the token, by token.get algorithm header. Means from the header it is going to fetch the algorithm value, and then if the algorithm is RS256 means asymmetric, then use the provided key as RSA public key. But if the algorithm is symmetric means HS256, then use the provided key as an HMAC secret key. Now the problem arises when website developers who subsequently uses this method assume that it will exclusively handle JWT signed using an asymmetric algorithm like RS256, and due to this flawed assumption, they may always pass a fixed public key to the method as follow. Right? So in this case, if the server receives a token signed using a symmetric algorithm like HS256, the library generic verify method will treat the public key as HMAC secret, and that is the problem. So this means that an attacker could sign the token using HS256 and the public key, and the server will use the same public key to verify the signature. You got it, I think, right? So we are just going to tell the server that the algorithm is HS256 even if the server is using RS256, and once we do this, at that instant server will consider that I need to verify the signature with the same key. So you can read all these. Performing an algorithm confusion attack. So these are the steps to perform the attack, but we will see all these steps once we solve the lab, right? And you need to exactly follow these all the steps. So this is the first lab of this section, means JWT algorithm confusion, and the first lab is JWT authentication bypass via algorithm confusion. So this lab I already open up here. Okay. Let's go and see what it needs. This lab uses a JWT based mechanism for handling session. It uses a robust RSA key pair to sign and verify the token. However, due to implementation flaw, this mechanism is vulnerable to algorithm confusion attack. To solve the lab, first obtain the server's public key. So first of all, we need to get the server actual public key. this is exposed via a standard endpoint. So sometime what happened, we see that this is another information disclosure vulnerability, we can say, that server exposes the endpoints which should not be exposed to the public. But here this is possible, this attack or this exploitation is possible if you get the server's public key. And how you will get the server's public key, which is by this. So server is exposing a standard endpoint, use this key to sign a modified session token that gives you access to the admin panel, then delete the Carlos account and you can log into your own account, and we have the valid credentials, username is Wiener and the password is Peter. So keep this point in mind, I will let you know. So let's go and we will solve the lab. So first of all, come here, go to the accounts, and I'm going to enable the burp proxy on my browser, and the username is Wiener and the password is Peter. Don't save. Come here and let's see, we have the request. Yeah, and as you can see, all these highlighted request contains the JWT. Okay, now let's try if we can access the admin panel or not. So we cannot access, of course, only administrator user can access this admin panel. Now the point is, the server exposes the shared standard endpoint, okay, which it should not. So jwks.json and hit enter, and you can see this is the information disclosure because server or the developer did not hide this endpoint. So if the server exposing this endpoint, then you can get the key here, right? So okay, before going to further, I'm going to explain the steps we are going to follow. So the first step is going to be obtain the public key. Fine. Step number 2, generate the malicious key. Okay, malicious key to sign the token. Fine. And number 3 is going to be modify the token. So modify the token, and number 4 is going to be sign the token, right? So these steps we are going to follow. So let's go, and first of all we are going to complete the step number 1, which is obtain the public key. And we obtained the public key because the server is exposing this endpoint, which is jwks.json. So now I need to copy this whole key, copy, come here and paste it here. Fine. So this is the key, and this is going to be its complete value. Fine. Now the second thing is generating the malicious key to sign the token, because we cannot access the admin panel, so we will do that. Okay. Go to the burp proxy and go to the JWT editor key. This I generated before, so I'm going to delete that. Now we need to before going to that, just see the token what we have. Okay, so this is the token, and I'm going to send this request to the repeater. Go to the repeater and just send this request, and you will see 401 unauthorized. So I'm going to double click on the header part, and here in the inspector you can see this is the KID value, and algorithm it is using is RS256, means this is the RSA SHA256 and asymmetric algorithm. Fine. Okay, now go back to the JWT editors key, and we need to generate a symmetric key first. Fine. not symmetric key, because the algorithm here we see, where is it? This is RSA SHA 256. Yeah, so we need to generate the RSA key, right? That's how we will know what key we need to generate. Now what we need here, instead of generating, we go back here and just paste this key value from here up to here. Okay, just copy that, go back to the burp proxy, and instead of generate, just paste that key value. Fine, this is the value, and click OK. So now this is the actual public key. Fine. Now right click on this and go to the copy public key as PEM. So copy that, come back here and paste that. So this is the public key as PEM. Now you need to copy this, go back to the burp proxy, go to the decoder and paste that key, and then encode this key as base 64. Fine. And take this value, copy, and come back here and just paste that, right? Now what we need to do here is, again we go to the burp proxy JWT editor, and we need to create a new symmetric key. And in the symmetric key, because we need to confuse the server for the algorithm, because the server is using algorithm RS256 and we need to confuse it with HMAC SHA256, right? So now just generate this key, this symmetric key, and instead the value of K, we are going to just paste the base 64 value which we generated before, means this one from the PEM key. Okay, and just OK. Now this one RSA, this is the public key, and OCT3600, this is the symmetric key, means HMAC SHA256. We just need to go back to the burp proxy, to the repeater, go to the, okay, now open this up, go to the JSON web token. We need to change the algorithm first. Instead of RS256, we are going to tell to use HS256. Fine, and let's change the username from winner to administrator. Okay, and fine, let's just sign the token, and we need to sign it with HS256, and make sure don't modify header is checked, and just click OK. Now go back to the raw and just send the request. So once you send the request, nope. Okay, let's see, delete this one and delete this one. Fine. Go to the repeater, back, send, unauthorized. Okay, we are going to create this one more time. So first of all, create the new RSA key, and in the RSA key we need to copy, take the complete key and just paste it here. Invalid key, why so? Yeah, that's perfect. And let's just make it a bit manage, and algorithm value of n, and at last this. Fine. So we need to generate it as JWK, and now as you can see, the format is absolutely fine. Now just click OK. This is generated. Now we need to copy this key as PEM. So copy it, and go to the decoder, Control A, and paste the new copied key and just encode it as base 64. So it's encoded. Just Control A and Control C to copy and come back here. Just paste it instead of this. Paste that here. Okay. Now go back to the JWT editor key, and here we need to create a new symmetric key. In the symmetric key, we need to generate this symmetric key, and instead of value k, fine, we need to paste that base 64 encoded PEM key. So paste that. Okay, fine. Now go back to the repeater and JSON Web Token. Here we need to change this algorithm to HS256 and the user should be administrator. Fine. And now sign the token with this key. Okay. And now just send the request again, and yeah, this time we are able to access the admin panel. I don't know what I messed up before. So as you can see here, we can access the admin panel now, and we have /admin here. Now we can go to the response, right click and show response in the browser, copy that, come here and just paste that, click OK, and we have Carlos user and Wiener user, and we have admin panel here. Go back to the burp suite, and to delete the Carlos account I need to copy this complete path, copy that, go to the raw, instead of /admin, paste that and send this request again, and 302 found, follow redirection, and the Carlos user is deleted. We have here congratulations, you solved the lab message and user deleted successfully, and now you have only one user, which is Wiener. So now right click again, show response in the browser, copy that, go back to the browser and paste that. Make sure your burp proxy is enabled at that time. Hit enter, and yeah, we solved the lab. So that's it for this video, and if you see the difficulty level of this lab is expert, so of course and definitely this lab is going to be a bit difficult, but if your conceptual parameters are correct and you have a good understanding at that instant, there is nothing to be more difficult. But here what I did is I just confused the algorithm. So if I come here and I click this, you can see here the algorithm is RS256 and it's using the public and private key to sign and verify the token. But in the last, if I click header again, you can see I'm using HS256, means I deliberately enforcing the server to verify the signature with symmetric algorithm, which is HMAC SHA256, and that's it. So hope you understand that. If you have any query, please put your query in the comment section. See you in the next video. Bye.